Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to the next class of CS103 computer programming. In this particular class, we'll talk about the user-defined functions, which is the chapter 6 of the book C++ programming. So in this particular lecture, I'll basically be talking about some of the usages of different functions, what are functions, how to define functions in C++, what are different properties of functions, and everything that is related to functions in C++. So what we've studied so far is a variety of topics. You're already aware of basics of programming. You're already aware of how programming languages have evolved. We're also aware of how we basically what are the basics of a C++ typical program. Then we discussed the input-output in chapter 3, which was followed by the control structures. In the first section in chapter 4, we discussed control structures related to selection process, where we discussed the switch statement and the if-else, as-if constructs. Then in the next chapter, we discussed the control statements via repetition. And in that, we discussed different types of loops like for loop, while loop, and do while loop. And this lecture is a continuation of the same lectures where we'll be discussing functions and how functions are defined. So without further ado, let's start with the lecture, with the chapter. And this is chapter 6 of your book. So first, I'll discuss the chapter itself. And then when we will, at the end of it, we'll see some examples where I'll quickly go through the construct and things. And again, I recommend that you basically watch both of them in together. So on one screen, you have got the code running and the concepts or theory. And on the other side, you have the code, which is basically the relative example or the related example. And you can kind of look at simultaneously at both. So I'll be uploading both of them into different videos, and that will be for you to analyze them simultaneously. So let's begin with chapter 6 then. In this chapter, we intend to learn about standard or predefined functions, as it is the heading of the chapter. We learned about user-defined functions. So of course, one is the predefined function. Some of those examples you've already seen, where the random function and, for example, the time function, etc., srand and other things. Even int main for that matter. But then there's this user-defined functions that you write on your own and how you can write that. We'll see that. We'll examine value returning functions. So those functions that return a particular value, how do they work? We'll explore how to construct and use a value returning user-defined function. So how do you define it and how do you use it and how do you construct it? So those are some of the basic points here. We learned about function prototypes, which is basically the prototype of function. What does it look like? We learn how to construct and use the void functions. We will discover the difference between value and reference parameters. We'll explore reference parameters and value returning functions. We learn about the scope of an identifier. So this is something that I've already talked to you about when you present here physically, but I'll kind of, again go through the whole topic. Examine the difference between local and global identifiers. Discover static variables. What is a static variable? How does it work? We'll discover that. Learn how to debug programs using drivers and stubs. Learn function overloading, and finally explore functions with default parameters. So what is default parameter and how does this work? What is function overloading and how does that work? We'll discuss all of these topics in the current lecture. So what are functions? Functions are something basically small standalone programs on their own, which are given some input, and on that input they perform a particular task and return the result of the task. So this is exactly the same definition that you find for the program as well, in the sense that the program also takes some input, it performs some function, some task, and then it processes the task, and then it returns the results of the program. In that sense, the functions are exactly the same. However, the difference between a function and a program is that a program is a standalone stuff. So it includes everything. It includes some header files, it includes some pre-processing directives, then includes a main function, and so on and so forth. On the other hand, a function is, like the name suggests, just a function. So it cannot contain other functions, it cannot contain other things. It can just contain code or the body of the function only and nothing else. While a program actually can contain multiple functions, multiple pre-processor directives, multiple other things as well, globally declared variables and whatnot. And that's not true for if you declare it in a function. So we often call functions as modules as well. Uh, uh, in terms of module, they are like miniature programs that can be combined to form larger programs. So you can combine multiple functions. They allow complicated programs to be divided into manageable pieces. So even if you have a very large program, functions help you, or they make sure that you can divide them into manageable pieces. Some of the predefined functions in C++ we have already seen a bit. In C++, for example, you have got a function is very similar to that of a function in algebra. So you might be aware of a lot of these functions that are present in algebra, and we'll be using them here. Function has a name, clearly, just like you have functions in algebra, they have a name. And then, of course, a function performs some kind of computation. You give it an input, and it performs some computation on top of it, and it then generates an output for it. So some of the predefined mathematical functions that you have seen so far are square root function, sqrt of x, that we've used a couple of times. We have already seen the power function, POW function, and then there's this floor function as well, for example, that floors the value of x. So whatever double you give it, 3.14 or something, it will find the floor value of this particular double x. So these are all predefined functions that are present in some header files. You just need to include the header file. For example, for these three, you need to include the CMath library or CMath header file, and it works absolutely fine. So typically, predefined functions are organized into separate libraries. For example, some of the IO functions, if you want to use them, you'll be including the IO stream header. If you want to use the math functions, they are available in the CMath header. And we have seen other examples of them as well. So for example, for the manipulation part, you have got the function which is called IOManIP. Right? To use predefined functions, you must include the header file using an include statement. You already know about it. And here is basically in table 6.1 in the text, it shows for some common predefined functions, and we'll see them in section 6.1 of the book. If I just maybe open the book for a bit and maybe just talk about section 6.1, I think that would be an excellent way to discuss the topic right away. And yeah, so I need to go to section 6. Okay, this is all the book. This is chapter 2, chapter 3. We have worked quite a lot, and I guess we can. So chapter 6, predefined functions. And yes, here it is. So for example, absolute of x is available in CMath library. Absolute of ceiling function of x is available. Cosine of x, exponential function of x, exponential of x again in CMath library. F absolute of x that you have seen, which gives the absolute value. It's also in CMath. You've seen the floor x, is lower x, which is available in the CC type library, and it basically returns 1 if x is a lowercase letter, otherwise it returns 0. Basically, is lower is a check that if every character is in lowercase or in uppercase, but you need to include the CC type library for it. Similarly, you've got is upper, POW, SQRT square root, to lower, again from CC type, and to upper from CC type. Right, so these are some of the examples here, and then it gives the first example in the book again, which uses these different functions and different things. I'll not go through them for now, but actually start off with the next part of the lecture. Of course, we'll be discussing that example when we go into the code section at the end of the lecture. Okay, so for predefined functions, those are built-in functions. You don't need to code anything, but you just are able to use them if you include the relevant header, and then you can directly use the function in your code. But the thing is, if you look at each function, they basically have a certain, for example, if I go back here, square root expects a variable x. This variable has to be a double or basically a square or something, so that the corresponding square root can be calculated. I think it's a double, so that you cannot put in a character in a square root simply. Similarly, if you talk about a bit about The power function here, POW, so it expects two variables, x and y, both may be integers here, and or maybe double or whatever. So you need to again respect the alphabets or the data type of the data type of the variables. Similarly, you've got floor x, so the data type is important of these. But these are something that have been pre-written, and these are available for you to use directly, and you can use them directly as we'll see in the example soon. But the other case is where you define functions on your own, and those are what we call the user-defined functions. And that is basically section 6.2 of the book, and I'll just go quickly over there. The main thing here is that in the user-defined functions, you actually define each and every single line of it, right? And the first type of the functions in user-defined functions is what we call the value-returning functions. Value-returning functions have a return type. So they basically return a value of a specific data type using the return statement. Like we've already seen in the main function, int main, it always returns 0. So it's something that's being returned. The return statement is very important. I've kind of skipped it so far because I never needed to use the return statement. But in case of functions, return function is return statement is extremely important. So what does a return function do? It basically returns a particular value from the current function back to the parent function, calling function, or the main exits the program. In case it is the return is calling the main function. So if you have got value returning functions that do return a value, the opposite of that is the void functions. The void functions do not have a return type at all. They do not return anything. So do not use a return statement in the void functions to return anything. So you cannot have a return statement with a value in a void function. You can have a return statement, but then you cannot have a value to return. If it is a void, it is not supposed to return anything. For value returning functions, if you want to use them, you must always include the appropriate header file in your program using the include statement. And you must know if it's a predefined function, of course, then you need to use the appropriate header file. If it is a user-defined function, then you need to include the corresponding header or the corresponding body of the function somewhere. You must know the following items. For example, you must know the name of the function. You must know the number of parameters, whatever parameters they have. Know the data type of each parameter. So this is something we discussed earlier on as well. And then finally, the data type of the value that is returned, which is called the type of the function. So for example, a function, if it returns int, then the type of the function is int. So the value returned, we need to know the data type and then use it correspondingly. So these are the things that are required for you to understand very well. If you want to use a function which is a value returning function, you want to know the name, number of parameters, if any, so you can have 0 or more, but whatever it is. In case you have parameters, then the data type of each parameter, and you must also know the data type of the value returned. We can use the value returned by a value returning function basically by either saving it in some place for further calculation, maybe in a variable or something, or we can directly use it in calculation. So if you are, for example, adding up some numbers, you can directly call the function in place of storing it in there. We'll see some examples probably. And then you have got, you can simply print it out directly and not store it anywhere or use it. So these are the three different scenarios of where you can use the values returned by a value returning function. A value returning function can be used in an assignment operator or in an output statement. But you cannot store something in a value returning function. So that is something that you need to understand, that a value returning function is actually returning something and not, it cannot be used as a storage place or, as per the normal usage, or even you cannot actually store anything. It does not have a memory allocated for storage. The heading or the function header is basically the first line of the function. So for example, it can be int absolute int number. So this is what we call the heading or the function header. I typically call it the function header. So this basically represents the name of the function as ABS, right? the return type is int integer, and basically the parameter it is storing is this. It requires only one parameter, which is a number of data type int. So formal parameter is basically a variable that is declared in the heading. So for example, number, if it's a variable that is declared in the heading, then it's this is the formal parameter. So in this case, the number here is a formal parameter because it is declared as int inside the heading. On the other hand, an actual parameter is a variable or expression that is listed in a call to a function. So that's the actual parameter. Formal parameter is a name number, but the actual parameter is what you will use in the call to the function. So for example, if you want to call absolute int integer, int number, you might call it simply by abs is equal to abs bracket 5. So 5 is your actual parameter, while number is your formal parameter. In this example, they have basically stated about power u, v. So power u and v are the actual parameters, while the one which is present there in POW, int x and y are your actual parameters. The x and y are your formal parameters. And we'll see those examples when we go by. So let's talk about the syntax of a value returning function. We need to mention the function type or the return type of the function, function name of the function, followed by braces. Then you need to give a formal parameter list, and then you need to give all the set of statements within braces, and you quit. So this is how a formal function is written. These statements can be compound statements, of course. These can be single statement. Note, however, that these braces are compulsory to be put in after every function name, regardless of if you only have even one statement, you need to put in these braces. And that's how a function is declared. The function type here is also called the data type or the return type, as I mentioned earlier. So if we look at a typical function, what is the formal parameter list? We notice that if you remember, we can identify all the identifiers by the data type. This is how you typically declare an identifier in C++. But let's look at this particular function. So this is a function where what we're trying to do is we are trying to find the absolute value of a number. So in that, the function heading is int absolute bracket int number close. This whole is your function heading. The int here is your function return type. This abs is your function name. This thing, whatever the number of parameters, these are all your formal parameters, and this is your formal parameter list. So this is a formal parameter, and you have got only one parameter in your formal parameter list, and the remaining part within braces until this last closing braces, this is what we call as your function body, right? So this is a really nice and really good introduction to a function. You basically have a function heading, which includes a function return type, a function name, a formal list of parameters, and basically a function body. So these are the, if I want to call it, you've got a function heading and a function body. A function body can further be divided into return type, name, and formal parameter list, where into three more things. So you notice that you've got a lot of these names here, and you need to remember these names because I'll be using these in the next slides a lot. So how do you call a function? If you can declare a function like that, how do you call a function? Well, the syntax to calling a value returning function would be the name of the function and the actual parameter list. So you need to provide the actual values here, or maybe actual variables from which values can be taken. And if this is true, then you can basically call the same function. So that is a syntax to call a value returning function, which returns a value. If you want to know about the syntax of the actual parameter list, it is basically expression or variable, comma, expression or variable, and so on. And if you know the options, well, one option is that the formal parameter list that is defined within the function body and function name, that might be empty. You need not necessarily give a parameter here, so it can be empty or it can have one or more parameters as well. However, a call to a function value function returning function with an empty formal parameter list will be function name. Again, this actual parameter list is left empty. So then I think we need to talk a bit about the return statement. The return statement is a very important statement that basically shows how or what value is supposed to be returned by a function. So a function returns its value using the return statement. It passes this value outside the function. So whatever is written here will be passed on to the return type, and that return type will be, excuse me, the return type will be visible to any of the calling function or whatever is outside the function. So the simple syntax for return statement is syntax return expr. In C++, return is a reserved word. You need to know that return cannot be initialized or named as a variable name. It is reserved. The syntax is really simple. You just need to give an expression here or a value, and that value will be calculated, and then that value will be returned, whatever that is. Whenever a return statement is executed, you need to remember this: the function will immediately terminate. It will not run beyond this point, and the control will go back to the calling function in case of a main. So here it is. When the return statement executes in the main function, the program will simply terminate. On the other hand, if it is used in any other function, the control will be returned to the calling function, whether it be main or any other function as well. And we'll see how that is done. So for example, here you have the function heading. In this case, you have a function body, and we see that double larger. So then this is the function return type, this is the function name, this is the formal parameter list here, and in these there are two formal parameters, one double x and one double y, and this is the body. So in the body we can see that double max. So we declare a local variable inside the function body. We may talk about, I've already discussed what a local and global variable is, but we'll talk about it soon in a minute as well. So this is the local variable of this particular function larger. If x is greater than equal to y, then we set max equal to x. Otherwise, we set max equal to y, and finally return the value max. So in this case, this is the function return value, and this will be passed into this. So max has to be double because we expect a double to be returned, right? So max is a double, as you can notice, and that is being returned. And in here, we're doing some processing, and finally, when we get the result, we'll just output it. This function will return whether x is greater than y or y is greater than x. It will return the value which is larger. So let's talk a bit about function prototype. What is a function prototype? A function prototype is basically what we call a function heading without the body of the function. So it is just the heading alone, and we usually end it with a semicolon. However, remember that it is not necessary to specify the variable name in the parameter list. Like in the original definition of parameter list, we actually have the name of the parameter as well. However, in the function prototype, we might not mention the name of it is not necessary, and if we mention it, it is still a prototype. But even if we do not mention the name of the parameters, it doesn't matter, and the function the prototype can be defined even without the names of the parameters. Just the data types of each parameter is a must to be specified, and that is the only requirement in this. The return type, the data type of each parameter list of the actual parameters, or the parameter list, so those need to be specified, and the function name needs to be specified. So for example, here is the function int secret int x, right? If x is greater than 5, return 2 into x. So if x is greater than 5, you want to return twice the value of x, and so this works fine. But there is a certain problem here. What if the value that has been entered for x is less than 5? In that case, nothing is being returned, and the problem would be if you run this on the code, it's going to give you an error saying that this is not executable because we expect an integer to be returned in each case. While there's a certain case here, if x is less than equal to 5, in that case, nothing is being returned. So what we need to do is we need to have a correct definition of the function, which would be int secret int x. If x is greater than 5, we return 2 times x. Otherwise, we simply return x. So with this statement, the double value will be returned. If we do not enter the if instead, then return x will be performed, and the x itself will be returned out. So let's take another example. You've got a return xy statement. The problem here is that if you have two particular values that are supposed to be returned, only the later value will be returned in the, because only a single value can be returned, or a single data type can be returned in the from a function. So only y will be returned. Similarly, if we declare int func z1 int x is equal to 45, return 23 comma x, in this case only the value of x will be returned and 23 will not be returned. Similarly, let's go to func return to int z. So there is one variable that you take as input, and in this what we do is int a is equal to 2, int b is equal to 3, int 2 into a plus b comma z plus b. So only the value that will be returned will be z plus b, right? So that's only value that is returned. This will not be returned. So you need to be very careful when you're trying to return a value. Only a single value, that is the last value, will always be returned. If you talk about how does the compilation work and the execution is performed, well, execution will always begin at the first statement in the function main. So whenever you start a program, it will always start executing from the first line in the function main. Any other function will basically be executed only when they are called from the main function or from some other function, right? The function prototypes will appear before any function definition. So you need to always define the function prototype at the top of your program before you start the definition. And number one, and actually before the function is being called. So if you do not write out the function prototypes before a function is called, the function will not be visible to the underlying function. So it's always a good programming practice to declare all your function prototypes right after the preprocessor directives, but before the first function, that is normally the int main function. So it's always a good practice that you need to remember to put in prototypes of all your functions at that right at the top. Compiler will first translate these into corresponding attached bodies to these functions, and then it can it can understand where the function is called and understand it correctly. And then, of course, it can correctly be translated to a function call. Function calls transfer control to the first statement in the body of the called function. So whenever you call a function, the control will be transferred directly to the first statement in the body of the called function. When the end of a called function is executed, control is passed back to the point immediately following the function call. So when the program ends, the control will be passed back to the point that made the function call. Right after that, the control will be passed on to that particular point. A function's returned value will replace the function's call statement. So whatever is being returned by the function, that value will replace the place where the function was called. Then another type of functions that exist is basically what we call the void functions. Void functions actually do not return anything, as we have seen already. And there are many different examples in the book of the value returning function that you need to see. And there are excellent examples that I recommend you to go and watch for sure. Example 6.6, 6.4, 6.3, etc. But I'll kind of move on with the current statement about the void functions. So the user-defined void functions can be placed either before or after the function main. So you can place them anywhere that you want. If user-defined void functions are placed after the function main, the function prototype must be placed before the function main. Of course, the function main, if the prototype is not visible to the function main, they cannot be called from the function main. But however, it's always a good practice to put in all your function prototypes right before the function main. Void functions are different from the value returning function in the sense that they do not return any value. They do not have a return type as well. The return statement without any value is typically used to exit the function early. So if you want to exit the function early, just use a return statement without any value. So return and semicolon, and that's it. If you want to, in void functions, again, the formal parameters are optional. You may or may not have formal parameters. A call to void function is a standalone statement. Again, it's a statement on its own, which does not return anything, and it has to be a standalone statement. Void function definition syntax is like this. So you have got a void mentioned at the start, exactly in the same case. So you need to have everything in lowercase, void, the name of the function, and then this is followed by brackets, and then a foreign parameter list, bracket close, another brackets, and basically all the statements. These may be compound statements or a single statement. However, it works fine. So a formal parameter list syntax is given here. We can also see that you have got a data type, address of variable, data type, address of variable, and so on. We'll discuss these address of symbols pretty much soon when we discuss pointers and addresses. Yeah, so these are something that need to be discussed. The function call is very simple. You basically have the function name followed by an actual parameter list. The actual parameter list may basically be an expression or variable, or basically, yeah, so that is what we can follow. It can be an expression or a variable, but it will be evaluated and compiled up into a single value at the end of the day. Okay, so what is a value parameter? A formal parameter that receives a copy of the content of corresponding actual parameter. So remember, a value, if you are talking about a value parameter alone, it will be a simple parameter that gets a copy of the content of the actual parameter, but not the actual parameter itself. So it's just the copy. And if you make changes in the copy, the original will remain unchanged. So whenever you have got a value parameter, you need to know that things in the value parameter cannot change. In fact, if you make changes in the value parameter, you're making changes to the copy, but not to the original one. The original one remains intact, and the original value will be reserved and safe, will be conserved. On the other hand, a reference parameter is a formal parameter that receives the location or the memory address of the corresponding actual parameter. This is not the copy. This is going to use the same memory address as that of the corresponding actual parameter. And in this case, whatever changes you're going to make will be reflected in the actual parameter as well. This is what we call a reference parameter. So this is a difference between a reference parameter and a value parameter. Okay. So if a formal parameter is a value parameter, if you define a formal parameter as a value parameter, the value of the corresponding actual parameter is copied into it. So you just create a copy first. It gets another space in the memory. You copy the value only into that memory space. And what we know is that the formal parameter has its own copy of the data. It's not the actual data now. If you change the actual data after this, the formal copy or the formal parameter data will remain intact. On the other hand, if you change the formal copy of parameter, if you change the formal parameter copy, then the value in the actual parameter will remain the same, and it will remain unchanged. So changes in one of these will not be reflected in the other type of parameters. However, during program execution, the formal parameter will manipulate the data stored in its own memory space and will not affect the other, the main data source. However, if a formal parameter is a reference parameter, then it receives the memory address of the corresponding actual parameter, and during program execution, when you manipulate data, changes to formal parameter will cause changes in the corresponding actual parameter as well. So there is just one place where you are causing the changes, and those changes will even be reflected in the actual parameter. How do you do that? We'll see that in maybe in a couple of minutes, I think. Yeah, so there are a lot of these different examples, some very good examples given in the book, and we'll discuss some of them in the coding part at the end of the current lecture. So reference variables as parameters are quite useful in three main situations. So of course, sometimes the value parameters are very important. At other times, the reference parameters are more important. And there are three particular cases or situations in which the reference parameters are extremely useful. When you're returning more than one value, in that case, the reference parameters are important. So remember, the function can only return one value, right? We cannot return more than one value. And because of that limitation, when you're using the reference parameters, you can actually cause changes in the actual parameters, and that change is going to be passed back to the main function. So if you're returning more than one variable or value, you can use the reference parameters handily. When you want to cause changes to the actual parameter, you do not need to return and re-operate on it. Instead, you can directly use the reference parameter to cause the changes directly into the actual parameter. Or for example, when you want to pass the address, or when actually you do pass the address of your function, of a variable in your function, in that case, as we'll see when we study pointers and address stuff, we'll see that it also saves a lot of memory space as well as time for passing, because you're actually passing just the address, and address is just one byte, which is much smaller than an int or a double or some other value. In that case, you're saving a couple of bytes as well as time to access and to get the data. When a function is called, you need to, so this is some of the nitty-gritty details of what happens when a function gets called. And this is something you need to know because you'll be using a lot of functions in your projects and stuff. So when a function value is called, the memory for its formal parameters and its local variables is allocated in the function data area. The memory will always be allocated in the function data area. And you need to know for the formal parameters and the local variables that are initialized within the function. We have already discussed a bit about the local variables, but we'll maybe discuss when we discuss the scope of a variable. In that, you'll understand what a local variable and what a global variable exactly is. We discussed that in the physical sections, but I think we'll actually also discuss them in this current slide soon. For a value parameter, the actual parameter's value is copied into the foreign parameter's memory cell. So the space which is allocated for the formal parameter, the actual the value will be copied to the for the value parameter, but not else. Changes to the foreign parameter do not affect the actual parameter's value. This is something that I've already said. Since they have got different memory spaces allocated to them, any change to the foreign parameter value will not be reflected in the actual parameter, and hence it will not affect the actual parameter's value either. For a reference parameter, however, the actual parameter's address is passed to the foreign parameter. Instead of getting an integer here or something, basically the actual parameter is initialized, the foreign parameter is initialized by the same address as that of the actual parameter. So in other words, both formal and actual parameters refer to the same memory location. During execution, changes made to the foreign parameter's value will permanently be changed the actual parameter's value as well. So when you're making changes to the foreign parameter, remember that those values or those changes will be reflected permanently in the actual parameter's value as well. So we can also use reference parameters in a value returning function. However, generally it's not recommended, because if you have got a value that is being returned, then you're able to return a single value via the return statement. And in that case, if you just want to have a single value that is being changed, and it is generally the case, each function ideally has a single value to return. Generally, it is not recommended to use reference parameters in a value returning function if you are returning a single value. However, if a function needs to return more than one value, then we need to change it to a void function and use reference parameters to return the values. So even in that case, a value returning function is not a good option. If you're returning just a single value, a return statement is good enough to work for you. If you're returning more than one value, it is recommended that you actually use a void function and use two reference parameters instead to return the values. So we talked a bit about the scope of an identifier earlier on. By scope, what I mean is that the place or the limit in which an identifier is accessible within the program. So at which places is the identifier accessible, at which places it is not. And in that, we actually have got two categories. We basically have a category which is called the local identifier and another category which is called the global identifier. The term local means something that is very much present within a certain scope, within a certain local area only. On the other hand, a global identifier is something which is accessible across different regions, across different functions for that matter. So a local identifier is an identifier that is declared within a function or block and is accessible only within that function or block. On the other hand, and by block, I basically mean, for example, for an for a for loop, if you declare something within those braces, they are only accessible within those braces. So you cannot access them within the same function even outside those particular braces. However, and you can try that. You must have already tried that. And we did discuss them a little bit. But these are something that we now are formally discussing, and this is what we call a local identifier to that block or to that function. That is not going to be accessible outside that function or outside that block. On the other hand, a global identifier is something that is declared outside of every function definition and is accessible to every function and to every block as well within those functions. So you can use them anywhere in the code you want. Those are what we call the global identifiers. Remember that C++ does not allow nested functions. So definition of one function, what do I mean by nested functions? One function inside another function. So you cannot define one function inside or included in the body of another function. Okay. So whenever you want to access an identifier, there are some certain rules that are being followed. For example, the global identifiers are accessible by a function or block if they're declared before the function definition, right? So before the function is being defined, they need to be, these global identifiers need to be defined before that, or declared before that. The function name has to be different from the identifier name, so you can't have the same name of a function as well as of an identifier. The parameters to the function have different names, so parameters to the function should be different from the global identifier. So for example, if you have a global identifier named x and you have a local variable or local identifier in the function which is also called x, then if you use the name x, it will always refer to the local identifier. And for example, if the value that is being passed to a function, the formal parameter list, if you cannot name them the same as that of a global identifier, otherwise only that thing that is being passed would be used. For example, again, if you take int x as a global parameter and int x being passed to a function, then wherever you use x, it will always refer to the x that is passed to the function and not the global variable x. So if you want to use a global variable x, you need to have a different name for the parameter of the function, as well as all the local identifiers that are declared within the body of the function should also have different names. So these are the 4 typical rules for global identifier to be accessed. Although I did give another way to access it, that is you can basically use 2 colons if you want to access a global identifier. However, it is only recommended that the same global name is not used across identifiers. So rules when an identifier is accessed, well, the nested block here gives something about the local identifier. If you want to access an identifier from nested block, well, the identifier accessible from declaration to end of block in which it is declared, the identifier is only accessible within the block. So for example, if I declare it inside a for loop, then it is only accessible inside the for loop block and not outside the for loop. So identifiers are accessible from declaration. At the time you declare them, you start using them until the end of the block in which it is declared. Within nested blocks, if no identifier with same name exists, of course, if there's a nested block, then and no identifier with the same name exists, then these can be used as well. Scope of a function name similar to scope of identifier declared outside any block. So function name must be declared outside any block, since your nested functions are not allowed. Hence, the function name is accessible just like a global variable. That is, function name scope is basically the same as that of the global variable scope. Some compilers initialize global variables to default values as well. So you're allowed to store or initialize global variables to default values as well. However, there's another very important characteristic that we call the scope resolution operator. And this is something that I talked to you about, how you can access a global variable when the same name local variable is also declared within the block and you want to access the global variable. The way to access that would be to use the scope resolution operator, which is these 2 columns. By using the scope resolution operator, a global variable declared before the definition of a function or block can be accessed by the function or block. So even if you want to access a global variable that has been declared before the definition of the function, you can access it inside the function using the scope operator. Even if the function or the block has an identifier with the same name as a global variable, still using these operators you can access the global variable. We discussed that a lot in the class, and this is basically Mr. Trump's lot. So we have discussed this variable a lot in the class. So to access a global variable declared after the definition of a function, the function must not contain any identifier with the same name. However, remember, if you want to access a global variable that is declared after the definition of a function, the function must not contain any identifier with the same name, because you cannot even actually use the scope resolution operator to if the variable is declared after the definition of function, we can still call it before in the function. However, in that case, the function must not contain any identifier with the same name, since we cannot also use the scope resolution operator for this particular case. The reserved word extern indicates that a global variable has been declared elsewhere. So an extern means where you will find this word, which is reserved as well. This only indicates that the global variable has been declared elsewhere. By using global variables, it has certain side effects. For example, a function that uses global variables is not independent. It is very much dependent on a global variable value that is outside. If more than one function uses the same global variable, sometimes it gets very difficult to debug problems with it, because there are multiple functions that are using the same global variable. Hence, you need to be careful which function is calling and what is happening to the value every time in the global variable. Problems caused in one area of a program may appear to be from another area. So a lot of times, if you're using global variables, the problem might be happening in one part of the program, but you are seeing it on the other part. So it gets very difficult to debug these kind of problems. Global named constants have no side effects. So if you name them as constants, of course, like we did before, then there's no side effect, and they can be, because they're constant values, the value is not changing, so they don't have these effects or defects, if you want to call them. Another type of variable is what we call the automatic variable. An automatic variable is basically memory is allocated at the block entry. So for a typical automatic variable, you assign memory at the time you are entering the block, and it is deallocated when you are exiting the block automatically. So by default, variables declared within a block are all defined as automatic variables. On the other hand, the static variable, our memory remains allocated as long as the program is executing. So for a static variable, which is not automatic, which is declared as static, the memory will remain allocated as long as the program executes. Global variables that are declared outside of any block are by default static variables, and they will hold their values. That's how the function works. We can declare a static variable within a block by using the reserved word static, like I said before. So the syntax here is static data type identifier. Static variables that are declared within a block are local to the block. So of course, any variable that is declared static within a block will be local to the block. It will basically have the same scope as any other local identifier in that block. However, the memory space allocated to it will remain allocated to it, but its scope is something limited. So for a global static variable, it is accessible everywhere. A variable that is declared as global will be acting as a static variable by default. However, you can also have static variables that are declared within a block. In that case, it is local only to the block. So what is a driver program? A driver program is a separate program that is used to test a function. So you write a function, and then you need to have a driver program that calls that function, and it tests that function only. So when our results are calculated by one function are needed in another function, we can use a function stub. What is a function stub? A function stub is a function that is not fully coded, but it helps check the values that are calculated by one function in a different function. So a driver program is something which separates, which is a standalone separate program that is used to test a particular function at a time. However, you need to use function stubs to kind of use a driver program. We'll discuss that in examples as well. I think there are a couple of these examples in the book, in the codes, which we'll discuss. But a very important topic is what we call function overloading. So this is something that is new for you, and we did not study it at all in the class. In a C++ program, several functions can have the same name. For example, you may have functions with the name double, or you may have um, uh, functions with the name square or something. So square can square basically an integer. At other times, it can square a double or something, right? So they may have the same name, but there's a certain difference here. In C++, several functions can have the same name. That's one thing. But in case of function overloading, what we do is we create several functions with the same name. However, another important aspect of function overloading is the function signature, the name and formal parameter list of the function. So it does not include the return type. It only includes the name and the formal parameter list of the function. Remember that it does not include the return type of the function. A function, when I talked about function prototype, the prototype and the function signature are two different things. In prototype, you have the return type followed by the function signature. In case of function signature, there is no return type. It just involves the name and the formal parameter list of the function. So two functions are said to have different formal parameter lists if both functions have either a different number of formal parameters, or if the number of formal parameters is the same, but the data type of the formal parameter differs in at least one position. So remember, two functions are said to have different formal parameter lists if you either have different number of formal parameters, or the data type of your formal parameters is basically different from the in both the functions. However, remember, overloaded functions must have different function signatures. So a function signature will differ by they'll have the same name. That's the definition of overloaded function, but they'll have different function signatures. That is they'll have a different formal parameter list in one way or the other. The one way is that you have a different number of formal parameters. So one function has got one parameter, the other has two parameters, or so on. Or the other way would be, even if they have the same number of formal parameters, even in that case, the data type of at least one of those formal parameters is going to be different from the other function. And we'll see these examples when we talk about function overloading in a couple of minutes. The parameter list supplied in a call to an overloaded function determines which function is executed. So of course, depending on the type of the parameter list, of the actual parameter list that is passed to that is used in a call to an overloaded function, that determines which function is going to be executed. Because both have the same name, so the function name will be the same, but the parameter list that is supplied will be different. And that is where the difference in the function signature becomes important. Notice again that this is function signature and not function prototype. Function prototype would have asked for a return value as well. A different return value thus means that we can still not access these. Okay, so function with default parameters. In a function call, the number of actual and formal parameters must be the same, right? Of course. However, C++ relaxes this condition for functions with default parameters. In case you've got default parameters within your functions, in that case, the number of actual parameters and the number of formal parameters may differ. And the reason for that is we can specify the value for default parameter in the function prototype. So the default value is something that is there by default. It always has a value assigned to it. So you can kind of, even if you do not specify the value for a default parameter when calling the function, the default value will be used and will be passed on to the function by default. So if you talk about default parameters, all default parameters must be the rightmost parameters of the function. So anything that is a default should be declared at the rightmost side of the function. If a default parameter value is not specified, if you do not specify default parameter value, you must skip all of the arguments to its right. Remember that all the arguments that are to the right side of it must be skipped. So those default values need to be skipped as well. So this is some kind of limitation with the default parameters. Everything that you declare default has to be on the right side of the rightmost side of the rightmost parameters of the function. And if you use a default value for one, if you do not specify it, everything on the right should also be skipped. Default values can be constants, global variables, or even function calls on their own. So remember, default values are not necessarily constants. They can be constants, they can be some global variables, or they can be function calls, whatever they are, you can use them. However, they cannot be local variables. Why is that the case? Well, they're not local variables because we cannot have nested functions, right? So without nested functions, the only variable that are accessible to a function in function call, in function signature or in function prototype are the global variables, right? So you cannot actually have, even the function calls are going to return a void or a value, right? So they also have got something that is to be returned. At the same time, if it's a constant, then it's a fixed value. However, you cannot assign a constant value as a default value to a reference parameter. So remember, reference parameter is the parameter that works with the address of a parameter. And hence, for a reference parameter, we are disallowed. It does not allow us to assign a constant value as a default value. So to summarize the whole talk and the whole lecture, functions or modules divide a program into manageable small tasks that we can then debug easily, and also see, perform a small subtask at a time. C++ provides standard predefined functions. For example, we saw the example of random function, we saw floor function, power function, and square root function. Two types of user-defined functions are basically value returning functions, those that return a value, and void functions which do not return anything. Variables defined in a function heading are called formal parameters. So these are the variables that are defined within the function heading. We call them formal parameters. And together, the list of formal parameters forms the signature or the prototype of the function. Expressions, variables, or constant values in a function call are called actual parameters. So when you perform a function call, you might be using the expressions, variables, or constant values. The function heading and the body of the function are called the definition of the function. So you need to remember a function heading, and together with the body of the function, that is what we call as the definition of the function. That is where the function is actually defined. So heading plus body is equal to definition of the function. A value returning function returns its value using the return statement. That is what you need to remember. A value returning function is always using the return statement to return a value. A prototype is basically the function heading without the body of the function with a semicolon at the end instead. A user-defined function executes only when they are called. So there needs to be a call made for user-defined functions. Remember that void functions do not return anything and thus do not have a return type. So void functions do not have a return type. There are two types of formal parameters. One is what we call a value parameter, and the other is what we call a reference parameter. A value parameter actually receives a copy of its corresponding actual parameter. It has its own memory space, and in its own memory space, it is just copying the value that it receives from the actual parameter. However, a reference parameter actually receives a memory address of its corresponding actual parameter, and it makes changes in the same memory address. So it does not have its own memory allocated. If you want to space memory, use reference parameters. If you want to use, but this causes changes in the actual parameter. So if you want to preserve your actual parameter, always use a value parameter. However, if you want to make changes to the actual parameter, use a reference parameter. Variables are declared within a function or block. That is the scope of the function or the variable. Those that are declared within a function or a block are called local variables to that function or to that block. Variables that are declared outside of every function definition or block are called global variables. So they're accessible to every function and every block. Automatic variable is a variable for which memory is allocated on function block entry. So when you enter a particular block, memory will be allocated for that variable, and it will automatically be deallocated when that function or that block is exited. And that's why it's not accessible outside that block. And we have seen the example of that in a for loop or something. So the static variables are variables where memory remains allocated throughout the execution of the program. So if you declare something static, the memory will remain allocated throughout the execution of the program. However, a static variable declared inside a function, which is a local variable, will not be accessible out when you exit the function. It will be deallocated anyway. So that is something that we need to keep in mind when you declare a variable static within a function. However, a global variable is by default static. A C++ function can have default parameters. So of course, yeah, you can have default values for parameters in C++ functions. So that brings an end to this lecture. I'll now start with some examples in the code, and we'll see how those look. So let's go to examples and let's see how they look.